Okay, so just like before, your first step would be to find your delta x. Okay, so we know that the integral from 3 to 8 is just another way to say from 3 to 8, which is your a and your b. Okay, so our delta x, which is b minus a over n, is 8 minus 3 over n, which is just 5 over n. Okay, your second step, you want to find the function at the left endpoint. Okay, so again, since we're using the interval x I minus 1 to x sub I, where this is your left and this is your right, the left endpoint, we'll have the intervals x sub I minus 1 will equal x sub 0 plus I minus 1 delta x. Okay, before it was just I delta x. Now it's I minus 1 delta x for the left. And again, if you just wanted a visual, okay, so let's say here, let me make that a little lower so I can draw a few more. Okay, so let's say you're just starting right at your left endpoints, and that's going to be touching the graph. Okay, so you have your x0, your x1, your x2, and the very last one, your x3. Remember, the last one's going to be your b, the first one's going to be your a. So to get to all of your left endpoints, you're going to start at x0 plus, to get to your first one, it's going to be 1 minus 1, which is 0, so it's just x0. To get to your second one, it's going to be x0 plus 2 minus 1, so it's x0 plus delta x, which gets you at this left endpoint. Then it adds one more delta x, and it keeps going from there. Okay, but just to remember the formula, if you're looking for the left, if you remember this part, the left is going to have I minus 1 times delta x, and the right is just going to have I times delta x.
So you just replace I with a sub of x?
Yep, you replace the I here with whatever your sub is there. So if you're looking for the right, I is just going to stay as I. But if you're looking for the left, that I is going to be I minus 1. Okay. So that means our x sub I minus 1 is going to equal our x0, because remember for this one, a equals x0 equals, where is it, 3 for this one. Okay, so that's going to be 3 plus I minus 1 times delta x, which is 5 over n. Okay, so if we went ahead and made this 3n over n, we can make it equal 3 plus 5 times I minus 1 over n. Oh, 3n, sorry about that. So all we did was rewrite it as 1.
Why'd you make it 3n?
Oh, because this 3, we just multiplied it by n over n. So we just turned 3.
Just to turn it into one big fraction. That's what you
Yep.
Okay.
Then multiply by n over n. Okay, so we know if our f of x is equal to 8x, then that means our f of xi would be 8 times xi. And we already figured out what our x sub I is. 8 times 3n plus 5 times I minus 1 all over n. I usually wait till later for that one, only because it's just easier to make it I minus 1. But we'll actually separate it a little later. Or you can separate it now. It's up to you. Okay, and this is our function at the left endpoint.
Is it not x sub I minus 1?
That's what I was
Could it be
thinking
x
too.
sub I?
Oh, I minus 1, thank you.
On all of this.
Yep. I minus 1.
On the 8 as well.
Yeah, 8xi.
Right, yep, 8xi minus 1. Thank you. Okay, so for our third step, now we're going to use the Riemann sum, and we'll do that on the next page since we're running out of room. Yep, he wants to leave that up there for a few more seconds. All right. So for our third step, we're going to use the Riemann sum and summation formulas. Okay, so for our Riemann sum, the sum from I equals 1 to n of f of x sub I minus 1 times delta x is equal to, we know our f sub x minus 1, so we have from I equals 1 to n of 8 times 3n plus 5 times I minus 1 all over n, and our delta x is 5 over n.
We're still I to 1.
Yep, still I equals 1. Okay, so we know that's going to equal, if we go ahead and multiply those two, that'll be I equals 1 to n of 40 over n squared. So what we did, we got those n's, brought them out, which just left 3n, and we can go ahead and distribute the 5 plus 5i minus 5. Okay, so just combining those two and combining those two ends. Now we just sort of separated everything up top. Okay. So now we distribute our summation. So you have the sum from I equals 1 to n of 40 over n squared. Oh, actually, we can bring the 40 over n squared and leave it out there since we're only changing the i's. So 40 over n squared of 3n plus 40 over n squared, the sum from I equals 1 to n of 5i, minus 40 over n squared, the sum from I equals 1 to n of 5. Okay. So all we did was just distribute everything. Okay. So if you remember, the sum from I equals 1 to n of I is equal to n times n plus 1 over 2. And the sum from I equals 1 to n of a constant is just that constant times n. Okay, so actually here we don't have any i's, so we can go ahead and bring that over. So this just becomes 120 over n times the sum of I equals 1 to n. You can leave that as just 1. Because everything else just went right over there. And one of the n's canceled out. 40 times 3, 120. Okay, so plus 40 over, actually you might as well multiply the 40 and the 5. That becomes 200. Over n squared times the sum from I equals 1 to n of I, minus, that becomes, 200 over n squared, the sum from I equals 1 to n of, let's put I, of 1. Is everything else factored over? All right. So we know the sum of a constant is just that constant times n. So this gives us 120 over n times n, or n times 1. Okay. Plus 200 over n squared times n times n plus 1 over 2 minus 200 over n squared. 1 times your constant is just n. Okay, so these two cancel out. So you're left with 120. That n and one of those n's cancel out. So you're left with 200n over n. Well, actually, let me stop skipping steps so go through the steps themselves. So you have 200 times n plus 1 over 2n. I'll simplify it in the next step. And this, you have 200, one of those n's cancel out, over n. So now we can distribute that one. So you have 120 plus 200n over 2n plus 200 over 2n minus 200 over 2n. Okay. So just so happens on this one. Oh, yes.
Oh, no, I see it.
Oh, no problem. Okay. And these two ends cancel out. You have 120 plus 200 divided by 2 is 100. Uh-oh, too many zeros. Here we go.
Why is the last one 2n?
That was in square.
Oh,
Yep, it was n squared. Oh, did I put 2 in? Yeah.
yeah. So it didn't.
Oh, yeah, this one should just be in, so it didn't cancel. That's right, that one. I don't know why I was looking at that one. Thank you.
I'm writing it like it doesn't cancel.
Yeah, I think I was looking at that one,
Yeah.
2 in, and it just carried over. Yep, so that one doesn't cancel.
So that just goes to 200 over n.
Yep, 200 over n. And that one stays. But really, after we apply the limit, it disappears, so it would have worked out, but good catch. So you have 100 over n minus 200 over n. All right, so that's I equals 1 to n, just bringing that all the way down here. F of x, I minus 1, delta x. Okay. So remember your fourth step, apply the limit to the right-hand side. Okay, so that gives us the limit. You can combine those two and just make the limit of 220 as x, as n approaches infinity. Plus the limit of 100 over n as n approaches infinity minus the limit of 200 over n as n approaches. Oh, that should be 2n. Let me make sure. Yep. Nope, 1 over n. I don't know what I'm thinking about. End of the day, I'm tired. All right, so this actually becomes 0, and that limit is 0. So you have 220 plus 0 minus 0, which is 220. All right, so any questions on that one? All right. I'll leave that up there for a few more seconds.
So anything with infinity on the bottom,
Oh yeah, if you have,
make it a 0.
yep, if you have any constant over n to any power, you might as well just, the limit automatically goes to 0. All right, so we do one more. And this one's just a little bit different because it only involves the first 3 steps. Okay, and for this one, you just want to find the limit definition. Of the definite integral. Okay, the integral from 7 to 13 of 4x to the 5th with respect to x. I'll put that underneath it, using a right endpoint. Riemann sum. Okay, so you don't have to work it out all the way through to the end when they ask you to just find the limit definition. The others we had to actually evaluate. Okay. Now the first step is just the same as the other two. You're going to look for your delta x first. So find your delta x. Okay, so we know that the integral from 7 to 13 is the same as saying from 7 to 13, where this is your a and that's your b. Okay, so our delta x, which is b minus a over n, is equal to 13 minus 7 over n, which is 6 over n. Okay, so the second step, we're going to find our function at the right endpoint. So find the function at right endpoint. Okay, so we know we have x sub I minus 1 and x sub I, where this is our left and this is our right. So that means we're going to use x sub I equals x sub 0 plus I delta x. Okay, and we know that our, little side note, our a equals x0, which in this case is equal to 7. So our x sub I is going to equal 7 plus I times our delta x, which is 6 over n. Okay, and if we make this 7n over n, that's going to equal 7n plus 6i over n, just to make it one neat little fraction. Okay. So our f of x, in this case, is 4x to the 5th, which means our f of x sub I is equal to 4 times x sub I to the 5th, which is equal to 4 times 7n plus 6i over n. Oh, into the, actually this is into the 5th, yep. And where's it? Nope, actually this is n and I didn't apply the 5th yet. So now we actually apply the 5th. So 4 times 7n plus 6i to the 5th over n to the 5th. Oop, clean that up just a hair. Okay, the reason we did that, we want to be able to factor out that n to the 5th at the bottom. Okay, again, this is our function at the right endpoint. Okay, so our third step is to use the Riemann sum and the limit only. We don't need the actual summation formulas for this one because we're not solving it. So use Riemann and the limit only. Okay, and that's because we're not solving. Not solving, just finding the limit definition. Now, if we were solving, we'd use the summation formulas. So bring that up just a little bit. Okay, so we have the sum from I equals 1 to n of f of x of I delta x. Kind of separate that a little bit. That equals the sum from I equals 1 to n, or f of x of I is equal to 4. Oh, did I forget? Yep, 4 times 7n plus 6 sub I to the 5th over n to the 5th times our delta x, which is 6 over n. Okay, so if we go ahead and multiply those two together and multiply those two together, we end up with the sum from I equals 1 to n of 24 over n to the 6th times 7n plus 6i. Didn't need the bracket, could have left it as parentheses. Don't know why I did that. To the 5th. Okay, so once we get this, we apply the limit. Okay, so equals to the limit as n approaches infinity. I guess you can say of 24 over into the 6th. Oh, forgot my sum. Do we need the sum on this one? I don't think you do, but nope, I don't think you need the sum for this answer. So you kind of replace the sum with the limit. Six I to the 5th. Okay, so this would be your limit definition. So it's a little bit shorter.
So,
Because on most of your problems, it'll be multiple choice, so they'll give you like 4 different options, and you just have to pick the right one.
So would there be a scenario where you do the limit with the sum?
If that's one of your options, but for the most part, because you're applying the limit as n approaches infinity, you'd have to factor all of that out 5 times and then find all of the places where the n's cancel out and all that. And yeah, for problems that big, it wouldn't even be, it's just too much work. So that's why for this one, they just left it like that. I mean, it's doable. It just would take entirely too long. All right, any other questions on this one? All right. Oh, anyone's still writing? Nope, leave that up there for a little bit.